And I've got, it looks like a workbench, but it's not. It's really a rod. Right there. And the rod is holding a sign. In fact, that rod is being held up with a cable. Whoa. And there's a sign hanging down from this rod, and the sign looks like this. And of course it says, in a subliminal way, I love
physics.
Sure. Go-kart. Okay, and there is an angle right here too. The angle here is 35 degrees. Not 35, sorry. I want to change it. Make it a bit more realistic. No, that's okay. 35. And this sign right here, the rod actually, has a mass equal to 5 kilograms. And the sign has a mass equal to 4 kilograms. And here are the distances. That distance right here is 3 meters. This distance right here is 4 meters. Just for round numbers. And this distance right here, the rod itself, is right up here, 5 meters. Okay, the rod is 5 meters in length. Okay, and given this, the question would be, and often is, what is the force in the cable? Because if you don't have enough tension that the cable can handle, if it's not a strong enough cable, it's going to snap. And it could take a wind, could take an earthquake, but you need to have a strong enough cable to hold the rod and the sign. Looks fairly complex. Let's try and simplify it. Free body diagram first. And free body diagram, like this.
I don't know why.
It's got a force here. And that's the force in the cable, also called the tension. It's got another force right here, which is the weight of the rod. And it's got one other force right here.
So there's an extra force acting on the cable on the wall.
Right. Yeah, well, we'll put those ones there in a minute too. And it's got the weight of the sign. Okay, and there are two other forces. They're right here at the pivot point. There will be a F, X, and an F, Y at the pivot point. So this right here is the pivot. That pivot is the hinge. I don't care about the forces on the pivot at all. All I'm trying to do is find this force right here. So if I can put the pivot right here at the hinge, I'll eliminate in the equation, the torque equation, this one and that one, okay? So if I was to try and solve it right now, just by going sum of the forces equals 0, I'd have one unknown, known, known, and unknown. So the force at the pivot, you don't know. You don't know this one. You do know this one. You do know this one. I can't use sum of forces equals 0. It doesn't work. Okay? I can't even use F left equals F right, F up equals F down. Because if I use F up equals F down, unknown, known, known, and I could break this guy up into its components, which I'll have to do anyway. That'd be F, C, perpendicular. And this part here is F, C, parallel. I don't know either of them. So even if I could go F up equals F down, I don't know this one, do know it, don't know it. And if I went F left equals F right, I don't know Fx and I don't know F, C, parallel. So it's not going to help me. So if I've got this situation right here, I can't use sum of forces equals 0. Yeah? Why, sorry? Right here? Okay, say that one more time.
Please say why is there like an FX force on
right here?
This one, but there's not on the table.
On the one here?
Yeah.
There really could have been, should have been.
No, on the other one, the
On the previous question? Oh. This one here? Right here?
Yeah.
Why is there an FX? Why isn't there? Oh, because there is no X force at all. So this force is up and down, the workbench is up and down, the leg is up and down. So the only force here would just be an up and down force. Yeah, it's because of the angle thing that you have an X force, right? So what she just said is, why is there an FX right here? It's because this tension in the cable is pulling the rod back this way, and at the pivot point it would have to be an equal and opposite force, okay? And that may be something that they would ask, I don't know. Okay? So just given this right now, I got 35 and what is this? 90 minus 35. 55. Right? Is that right? So 55 degrees right here? Okay, it doesn't look like it, but it is. I just didn't draw it quite right. Okay, so we got 55 degrees right down here. And what they're saying is, find for me what the heck that is. Because if I could find the upward force here, the force of this cable straight up, then by trigonometry I can find out what this force is right here. Okay? So got sum of forces equals 0, doesn't help. And it's because there's two equations, or one equation, two unknowns. So we have to go to torques. So torque clockwise equals torque counterclockwise. If I choose my pivot point right here, then I could say clockwise torques are weight of the rod times this distance, which is half of 5, so it's 2.5, plus the weight of the sine times the distance to the sine, which is 4. Are there any other clockwise torques? Counterclockwise torques though? There's a part that's counterclockwise from part of the force in the cables. So it's force of the cable perpendicular times that distance right here, which is 3 meters. So known, known, unknown. I'm going to find this component, this part of the cable. So if I can find that part of the cable, knowing the geometry and trigonometry, I can find out the full force of the cable. So I need to find this guy right here, the force of the cable perpendicular. So can you guys put your numbers in and find out what the force of the cable perpendicular is?
9.5.
Weight of the rod. 5 times 9.8 times 2.5. Weight of the sine, 4 times 9.8 times 4 is equal to force cable perpendicular times 3. So we should all agree on what force cable perpendicular is. What do you guys get? Okay, one more time, loud and proud. 93.1.
93.1.
Beautiful. So 2. Anyone else?
No.
Verification?
I got 93.1.
Nice. Okay, so if we got 93.1, and that's force of the cable perpendicular, it's only part of the force. You have to find the hypotenuse, that's all. So you've found this part right here. If I draw that whole vector, force of the cable, you have just found part of it. This part, right there. You found 93.1 newtons.
What is the question?
So the 93.1 newtons is only part of it. You want to find the hypotenuse though. Okay, we've got geometry. That was 55, so this has to be 35. And then there's your 90-degree angle. And you're trying to find the hypotenuse, okay? You've only got part of it. So for me, the easiest part would be cos, probably.